phase one to demonstrate the different angles. So at the moment, the readings, this would be the 0 position where the rest position is. And then I'm going to demonstrate how it's going to go to 45 degrees. And then I was going to go to 180, 90, 160 degrees as well. So that is 45 degrees where it is right now, as you can see. So we'll do the 160 degrees. So here is 160 degrees, and that's where it is. Phase two, so just to demonstrate the readings that we're getting from the assembly. So at the moment it's paused, so if I go into auto scroll, we can see that the readings fluctuating. So in the x-axis, we're getting sometimes 1.0, 0.5, in the y-axis, 0.20, and the z-axis 0.7, 0.5. So if I was to manipulate the device, like move it around, we can see that the values change. And if I manipulate it some more, and then I pause, we can see that the values are also changing. So for example, in the y-axis, we can see that the values sometimes fluctuate into the negative, same as in the y-axis, they fluctuate into the negative as well. So to take an average reading of that would be roughly around 4. Same thing with the z-axis as well, even though z-axis is demonstrating a positive value at the moment. So that seems to be working fine. Phase 3, so at the 0 degree position, this is where we've got the greatest speed, so mimicking ballet dancers, because the weight is at the center of rotation. This makes the weight inward, so the energy is transferred in through the axis of rotation. But if I was to move this to the maximum, which would be 160 degrees, so at 160 degrees, we can see that the weight is way out of the axis of rotation. So that makes it tricky because the inertial forces are being thrown outwards. And so this creates unnecessary energy on the outside. And then that reduces the speed the greatest. So it goes the same thing as if we were to put it at 60 degrees. There is a reduction in the moment of inertia because it's being brought back inwards, and obviously that also increases the speed as well because we're sort of bringing the weight back to the center of rotation. So if I was to put that back in, yeah, so we've brought it back to 60 degrees, and as I explained before, so what is happening is we're bringing the weight back near the center of rotation, and then that means there is no unnecessary energy being thrown on the outside as we're bringing it all in, and that creates less heat in bringing it back, and that's sort of like the analogy of how it works theoretically. So test one, just gonna have a look at a few readings here. So looking at the gyro as well as the accelerometer. If I go into auto scroll with it stationary, we can see that the readings in the, so looking at the accelerometer on the z-axis, we can see that we're reading 1.15 mostly because it's obviously stationary. But if I was to move that up and down, we can see that when I move the accelerometer, we're getting some readings that go into the 0.90. So we've got here 0.88, 0.94, 0.80, and this is all from the movement that I've just done, taking it up and down. So we can see that on the gyro as well, we're getting readings that range into the 24, but if we were to scroll up a little bit, you know, based on the timeline, sometimes we'll get readings in the negative, which is 0.49 here, 0.11. So it shows that the gyro readings, if I take it up and down for the z-axis, we can see that these readings, they're fluctuating as well. But if I was to go on the device itself and try and spin it, I can do it with one hand. So it's a little bit sensitive. So at the moment it's in the center, probably didn't. Center position. So we can see that that actually rotates for a while, and it's very fast as well. So initially I rotated it and it was rotating very fast because the weight was in the center, but I have so if we were to go and do it again, and then so it moves outwards, we can see that the weight has moved outwards, and that significantly slows it down. But as it starts to come back in, we can see that it wants to rotate, but because it's already back in, it's not going to rotate as fast. So that's probably at about 45 degrees, and it's come back in, but it won't rotate as fast because the weight initially was outwards. So test 2, I'm just going to rotate that a little bit while it's still on the table. And we can see that it's rotating pretty fast. So giving this some more rotation, we can see that it's moving outwards, still on the table. So I'm just going to do a demonstration that by manipulating the z-axis and tilting it at an angle, that might significantly outbalance it and reduce the speed. So looking at that, that significantly reduces the speed and more fluctuation. So something like that.